Welcome to OpsTok, the podcast where we delve into the fascinating crossroads of operations, technology, and business excellence. Your hosts, Sahand and Tom, are thrilled to have you. In today's episode, we are honored to have Chris White, a renowned supply chain leader. Chris's expertise is in the use of digital twin simulation for stress testing supply chains, ensuring robustness and efficiency against the toughest challenges. Chris is a published author and a respected instructor dedicated to educating the next generation of supply chain professionals. Chris brings a comprehensive blend of knowledge and proven expertise to our conversation today.
Hey, Chris. Hey, Tom. Chris, so
Hey.
great to have you back again. The last time we had a conversation, both Tom and I were just like talking about how interesting it would be to see the actual software that you were mentioning, Beer Games on Steroids. So really happy that you could make it back on the show and really
Yeah.
give us a hands-on demo of how to use it, how it works.
You
So
bet.
take it away.
Okay, well, thanks. Yeah, it was definitely a fun conversation for me, and I always like talking about this stuff, so I'll gladly walk through this. So what we'll do is build on the Beer Game on Steroids discussion. So Beer Game on Steroids is our free tool that we provide anyone that's in the supply chain world, mainly professors and instructors that they can use in their courses. And so we'll walk through some of that. We as a business do more complex supply chain simulation, but it's a lot like this. It's just easier to go through this. It's simpler for a quick discussion. And so I assume you can see my screen right now. Is that correct?
Yes,
All right.
that's great.
Yeah, that's great.
So what I'm running, Beer Game on Steroids, if you go to our LinkedIn page, there will be a link to an installation file, and it is for PCs. I am running a Mac, so I'm running a Parallels environment here. So you're seeing a PC program on a Mac. So, it is possible to run them on Macs as well. You just got to get one of these emulator environments. So we're looking right here. So hopefully you can see the layout. This is now Beer Game on Steroids, very simple. And the layout is such that over on the left, you have this palette of what we call bricks that you can use. And there's a factory, a warehouse, and a customer. So it's very simple, just three things. A factory makes something, in this case, beer, but it's whatever you want, as far as the program cares, it's just making something. And a warehouse just passes through. So it's collecting inventory. It's a distribution center, something like that, where it's going to collect inventory. It's actually just not making anything. So you still have inventory correction loops and management going on there. And then you've got the customer, which in this case is just a demand profile that puts demand on the system. So a very simple model. All you're doing is now dragging and dropping these over into this workspace. And you'll notice as I drag a factory over here, some variables become available. And so in our overview and tutorial decks that we have on the Beer Game on Steroids page, we actually walk through some of this. So this is a model that Dr. John Sterman at MIT, he's with the System Dynamics group at MIT. It's in his book called Business Dynamics, which was published in 2000. It's a widget model. So we are just using his widget model. It's embedded in here. It's an agent now. And so when I drop a factory on here, it's John Sterman's widget model behind the scenes. And these are some of the inputs that are allowed in that model. And so in the tutorial, we would describe that model. So we don't need to get into a lot of details. Just know it's a very basic model of producing things and then maintaining some finished goods inventory, some ordering, all that kind of stuff is happening. But there's manufacturing cycle time. What's my inventory adjustment time? What's my safety stock coverage? You have some variables like that. Then I can drag a warehouse on, and now you'll notice on the right, all the input variables, it's actually the same, except the production related variables aren't there. So we modified John Sterman's widget model to remove the production. So this is now just, like I said, a distribution center or a warehouse. And then you have a customer. And you'll notice now the customer only has a couple of things. Where am I ordering from, and what's my order pattern look like? So it's very, very, very simple. So once you've laid some things out, it's basically just drag and drop, or drag in and connect. And I've now created a supply chain, a very simple one, with a factory that makes something, sends it to a warehouse, and now I've got a customer. So very, very simple. What I'll do is I'll come to the actual beer game in a second, because we typically start with in our lesson plan that we provide. You can professors and instructors can do whatever they want, but we'll provide them with, here's how you actually build the traditional beer game, and then from there extend. But let me just kind of walk through this real fast. And again, a very, very simple model. And so, for example, with I've got the customer selected, and I would look, and it's just a very simple input. Again, when we do this for companies, it's a lot more complex, but since this is free and easy to use, all I'm doing is saying, hey, you're going to start with 100 a week, 100 cases a week, or 100 of whatever you happen to have in the simulation. But I can come in here and say, gosh, in week 10, I want that to increase to 120. That would be a typical beer game kind of thing. And now the other thing I would do here is simply say, where am I getting my orders from? And I'm getting 100% of my orders from the warehouse. That's the only thing I'm connected to. So if I was connected to 5 other warehouses or factories, we'd see them all listed here, and I'd break out my percentage of orders for each of them. This is very simple. I'm only connected 1 here, but you also notice there's this slider bar. So through the simulation, I can make changes. So I can go from 25% to one supplier, 75% to a second one, and then halfway through the simulation, switch those and show the adjustment time, how everything now adjusts to that change. So this is as basic as you can get right now. I'm going to leave all default variables the same just for the heck of it. And here I would go in and say that that warehouse needs 100% of its orders from the factory. And the simulation knows that the factory is the end of the chain, so it's not getting from anybody. There is behind it some little raw material thing just to make it work, because it's the end of the chain and it's got to get something. And so that's your basic model. And let me switch from that. We could play around and show results. And what I want to do is now instead switch to one that I've already pre-built and already have the output developed.
Oh, that's great. Yeah.
So this is now, and you can rename things as you put them on. And so this is now your traditional beer game. I got a beer factory that sends beer to some warehouse that then sends to a distribution center and on to the retailer. And here I am as the customer. Now, what I've done, I'm going to delete this right now. We're going to play around with a situation where a competitor comes in just for the heck of it. So right now, I'm going to disconnect that and just leave it as the customer. And I'm going to take a very simple situation where the customer is ordering 100 and stays at 100, just for the heck of it. And then we can run a simulation. And I've run that simulation. There's a lot of straight lines. And so that's typically what, a steady state situation looks like. And what the model's doing is figuring out based on cycle times, based on safety stock, inventory correction. It's saying this is what everyone ought to hold so that customer at the end gets 100 every time period. In this case, it's a week, 100 every week. This is what everyone ought to be holding. And you'll notice if you can see this 400 up here. So this 100 is that ordering. And then this 400 is a lot of the different inventories at the different levels. I'm now looking at inventories for the factory, the warehouse, the distributor, and the retailer. Now, this doesn't look that exciting because, nothing's really happened here. So now let me go in and I'm at the customer again, and let's do our beer game setup where I'm going to go from 100 to 120 at time step 15. I'm going to rerun the simulation. And of course, we begin to see this bullwhip effect that everyone, the game is well known for. We see down here a bump in orders. I went from 100 to 120. So notice that's pretty simple. It's just a step demand increase. But now we've got all this ripple effect. And the ones that are a little shallower are the retailer and the distribution center, and it kind of grows. And then this bigger one is now the factory, of course, at the end of the chain being a little bit. So we just replicated the basic beer game. And if I wanted to, I could come in here and have a little more fun and say, but let's go to, say, time period 25, and let's drop down to, let's say the customer drops down to 90. So now we're 100, 120, 90. Very simple, playing around. And now we can run and we can begin to now see how everyone's adjusting their inventories. Everyone's an independent agent. The retailer's trying their best to maintain their inventory. And then they're ordering back to the distribution center. Distribution centers trying their best to maintain their inventory and ordering back. And so you see this little, here's our demand that went up to 120 and down to 90, has now created all this chaos. And in the end, everyone settles down and almost gets back to an equilibrium. So this right here, when you hear terms like resilience and responsiveness of a supply chain, this is it in action. And this is, you recall in our previous discussion, we talked about going from top to bottom to top, where there's large disruptions or large changes. When it's just minor, usually the tier one and everyone kind of at the top of the supply chain can handle that. But you got COVID, you got toilet paper, you got the PPP, you got all those things happening where they are sucking that supply chain dry. And what you've got to do is see that demand pattern go all the way down the tiers of the supply chain. And then the material now starts to fill that back up. And what does that overall look like? So when you hear the terms resilience, responsiveness, all these curves, that's what that is. How high they go is my responsiveness. It's and my resilience of well, am I gonna, do I overreact and underreact, and how big do I react, and what is that delta? What's my highest and lowest? And then the responsiveness is also this time period of, well, notice this all happened way back here in the week 15, 20, 25, and I'm here at week 100 where I finally basically get back to equilibrium. And you could claim that maybe back here and somewhere around 90 you're heading toward equilibrium and you're close. But until then, you don't have any guarantees of what's kind of happening. And so that's just a very good example of when we talk about resilience and responsiveness, it's looking at the response, how the full supply chain over time, everyone reacting and doing their best, how that plays out over time. So that's just I wanted to play around with that. But what's interesting here is, now let's go back to this customer. I'm gonna change this secondary. I'm gonna take that off. So it's back to the 100 bumping up to 120, and we can go back and look at the rerun, and sure enough, we're back to that original chart. So I want to kind of start there with your traditional beer game. But what I'm going to do is I'm going to add a competitor now. So there's someone else drawing from the same retailer that I'm drawing from. Very, very simple. Of course, we could have 50 factories, 50 where, you could see we could just add to this. And that's where the instructors and professors can just have fun, add more tiers to it, add more factories. What is it, how does it help to get directly from a warehouse instead of from a distribution center retail? How, if I remove layers of the supply chain, what happens if I increase it? If I double up on suppliers, you can do a whole bunch of stuff. But here, just adding a competitor is all we're doing. And that competitor says, I'm going to jump in, and at week 20, I'm going to double my orders. So our customer, in fact, let's make an even more obvious situation where let's say we're that customer. We stay at 100. We didn't change a thing. So we're at 100, but a competitor is now connected who doubles orders. So now, even though I did nothing, I'm going to be impacted. We're going to show. So if now I run the simulation and I'm looking at inventories. Now these are just my inventory. Sorry. So that's why everything's straight line. Oh, sorry. This is where the simulation makes sure you've connected everything. Right here, I got to connect that and say that competitor is getting everything from our
the same distribution or retailer. Yeah.
So now this looks very similar. Now remember, we did nothing. We as the customer, we're the customer in this game, have just kept doing the same thing. But we can see all these reactions in the supply chain, even though our straight line right here stays the same. The shape of this curve is a lot like what we saw before, but the scale, you can't quite tell. It's now a lot bigger than it was before. We were, up and down a couple hundred. Now we're several hundred up and down. But I've added a page on here where I'm looking at the receipt of orders. And this is what I ordered. I'm the straight line right here. And for a period of time, because our retailer does not have infinite capacity, in this case, I actually am impacted, even though my orders didn't change. And this is where the whole supply chain dynamics and this idea of doing network optimizations and all that begins to lose some of its power, is that I am not the only player in this system. And no one has infinite capacity. Everyone is always adjusting. And it's that dynamic adjustment over time that really determines what your supply chain can do. Not have I set everything up optimally to meet this one set of conditions. It's as the conditions change, what happens? And so this is a very simple yet powerful to me example of I did nothing, but because I'm part of this network, I am now impacted by other things happening in the network. Makes perfect sense when you walk through the logic of it. But we, as we run businesses daily, often just look at our part of the picture and assume that, well, we ordered 100, we'll get 100 because we ordered 100. No, the supply chain will give you what the supply chain is capable of giving you based on how everyone has reacted and responded. And so this is just an interesting example where we drop, and it's not huge. We're down to like 95 or 96 cases instead of 100 for a period of time. And then for a while, we've got to kind of catch up because we didn't get those. And so now they come. And so even in our receipts, we get less for a while and then we get more for a while. So we even see the beginnings of that bullwhip effect. Those oscillations begin to happen. And so I'll make a comment about oscillations that is your real indicator of what's happening in the system. We are adjusting over time. We never, when we adjust, we never kind of go hit that exact amount perfectly. It's always because there are delays in the system, delays in decision-making, delays in materials coming, there's going to be some overshoot a little bit, always by nature. And so the delays in the system and the shipping times and all that begin to cause some of that. But anyway, very simple example. I hope that was kind of useful of how the beer game can be used, and maybe even talks a little bit about just resilience and responsiveness in general and why some of the tools. I think we're past this idea of looking just at tier ones and distribution centers and things and what's happening at I'll call it, we talked horizontal and vertical. That's that horizontal, two-dimensional top of the supply chain. You got to get deeper. You got to dig into the tiers. You got to go vertical to understand long-term, what's my supply chain capable of? And if I have these major disruptions, how do they really play out over time?
That is awesome. This is fantastic. Really great to see it. And thanks, Chris, for showing us this. I mean, even with this one sort of simple and straightforward simulation, the bullwhip and the effect on the factory is just amazing to watch. So yeah, this is great. Thank you so much. This is exactly what we would have loved to see and show our audience. This looks really fantastic.
You bet. Well, thanks for giving me a few minutes to walk through that, and I'm glad that was helpful.
Yeah, thank
Absolutely.
you, Chris.
Thank you.